In this video, I'm going to provide an example of steps that you may need to take to clean a data set so that the variables and the values of the variables actually represent what they're supposed to. And so Stata can recognize them as you, the human, does. Oftentimes, if not every time, I receive a raw set of data, there are either errors in the data or issues with the way the data is stored that I need to fix or clean before I can analyze the data in Stata. We'll start here opening up the MLB team values dataset I've provided. And once we've loaded the data, let's go ahead and take a look at it. So we're going to type browse in the command window, or just bro if you like. As you can see, this has every Major League Baseball team. And the variables here I've labeled V1990 through V, let's see how many years I have. It goes all the way to 2016. And this is the value of the team. Now, how do we know what that means if I didn't tell you? Well, let's see if I labeled the variables. That's a good indicator. So one thing we can do is open the sidebar here, and you can see, sure enough, it says current value in dollars, which are in the millions. And for some reason, this variable label is in all caps. I'm not sure what happened there. And this one doesn't say it's in the millions. Finally, the last one just says current value. Now, this is not a great labeling job, probably done by myself. Because what do I mean by current value? In reality, these are all recorded in dollars. And as we've discussed before, the value of the dollar in 1990 is not the same as the value of the dollar in 2016. So before analyzing anything here, we'll probably want to convert these to real values using the CPI like we did before. But this is a good example of how messy data can be that you receive. As time goes on, datasets do get more polished, depending on who is the person or organization providing them. But this is not uncommon to have issues like this. All right, we'll close the sidebar. And this is what I always do when I'm using a new data set. You just want to open it and look at it. Maybe do some summary statistics like we did last time, maybe tabulate some values, make sure you have what you think you have. But just looking at it, we see there are already some issues. For example, if you look at the value in 1998, it is in yellow, indicating that it's a string variable. The reason for this is we have values with characters in them, NA or not applicable. We don't have any team values for teams like the Arizona Diamondbacks, the Colorado Rockies, the Miami Marlins, and the Tampa Bay Rays here before the teams existed. And in their first year of existence, for the Arizona Diamondbacks, we see here a value of NA, meaning not applicable. So it must be that the way this organization who provided the data was calculating the team values didn't work for a team's first year of existence because we don't have the value here. Now, NA is different from missing, so clearly it means something different. And if we had a user guide to this data, hopefully it would explain that. But here we just want to switch it to missing because, well, we don't know what the value is. We also want this value to be a numerical variable. Let's take a look at some of the other data and see if there's any issues. We see here in 2004, we've also got a string variable, even though it looks like numbers, because when we come down here to the 19th row, and I don't see what team that is in this view, there's a $sign. And although Excel might recognize that as a value and understand that it's in dollar units, Stata just sees the $sign as a character, which it is. You'll have the same issue with commas as you see here. Although Excel will just display a comma to you, the user, and store the number as a number, Stata reads a comma as a text character. So these are issues that we will have with numerical variables if you import them, particularly from Excel, where they might still have $signs or commas on them, or NAs for not applicable. You'll also see that sometimes when you get the data from R. Now let's scroll through real quick, see if there's any other interesting issues we find. Ah, yes, here we are. And in 2016, clearly, these team values have a different format. Now we have M's and B's on them. And as you might guess, the M's are in millions of dollars and the B's are in billions of dollars. So we don't simply want to get rid of these M's and B's, because if we do, this team will look like it's only worth 1.175 million compared to this 925 million. We'll have to also figure out how to change this decimal to indicate that this value is actually more than this value. All right, let's do some more checking before doing any analysis here. So I said this should contain all teams of Major League Baseball. That's what appears. And if you think about how we can check that, since team is a string variable, we can simply tabulate team and make sure we have everyone. Well, actually, we've got 31 teams when MLB has 30. Let's see, we've got one of each, so there's no duplicates. But if you recall, or if you're a fan of baseball, you'll see that the Montreal Expos are in here. And if we scroll down, so are the Washington Nationals. And that is actually the same team, because Montreal moved to Washington. And so we have this choice again we'll need to make. Do we want to count that as the same team and just call it Washington the entire time? Do we want to count it as separate teams? Do we want to count it as separate teams and perhaps drop Montreal because we're going to be looking at more recent data? It's up to you. It depends on what your research question is. But again, these are the steps we talked about last time, just looking at the data, summarizing it, making sure it makes sense. And we do find some issues. We're going to have to correct some of those value variables. Another way we could have seen this is to describe the entire data set. So if I just type describe without typing any variables, it will show me all the variables and the terrible labels I made. And again, you can see here some of these value variables are actually strings. Most are integers. For some reason, 2002 is a float, which has decimal places, so that must be the first one with a decimal, I suppose. And the others with decimals, maybe they're stored as strings. But in any case, we want all of these to be numerical variables. So one command we can use that is very useful, that you will use often, is dstring. We want to dstring the variables and make them numerical. So once again, you can type help dstring to figure out how to use this command. And as you can see, the help file will tell you that you can type dstring, and in brackets it has a variable list. These brackets mean you can type, if you want optionally, the variables that you want to dstring. And I believe if you don't type anything, it'll try to dstring every variable. After the comma, they always list options. And the options here you must use are generate a new variable. So when you dstring the old variable, you generate a new one. You want to tell Stata what that's called. You get to choose what the name is. Or, this is the or operator, or you can use replace. If you say replace, it'll keep the same variable name. You'll still have that same variable, but it will replace the string values with the numerical values. If you're certain that your dstring operation is going to work, you should use this. But be very careful, because once you dstring a variable, the old information is gone. So if your dstring didn't work as planned, you can't go back. So just to be safe, what I'm going to do this first time is I'm going to type dstring, and let's see which one needs destringing. Here we go, 2003. Let's dstring v2003, and I'm going to say generate, and I'm going to call this variable test, because it's a test variable. We've never done this before, presumably. And so I want to look at the results to make sure I know what's going on. This is a good way to proceed. As I see here, Stata says all characters are numeric. So it didn't find any string variables. Everything was a number. So test was generated as an integer. And there's one missing value. Well, let's see what happened there. Let's describe test. Sure enough, it says it's an integer. It has the same variable label as it did when it was a string. And this is a small enough data set, so we can go ahead and list the values of test. So if I look, these are all numbers. So everything looks good. We have one missing. And I wonder why that is. Let's do this. I will list team and test. And sure enough, it was the Washington Nationals, which did not exist in 2003. So that actually makes sense. We're all good here. But what we really want to do is compare this value to the variable it came from. So let's go ahead and list team, the test variable, and v2003, which it came from. We want to make sure these are all the same numbers, and sure enough, it looks as if it worked as planned. And if we were to browse the data instead, so if I browse the team, test variable, and v2003, We can see again they are the same numbers but different colors because our test variable is actually an integer, whereas the original for some reason was a string. Now looking through this data, they were all numbers, so I'm not sure why 2003 was a string variable. But again, these things are common. These human errors or issues are common. And it may actually be, I made this data set a while ago, I may have done this on purpose just to show you how to fix the problem. But without me sabotaging your data, trust me, you'll find other issues that you need to fix in a very similar fashion. So now that I know it works, perhaps what I really want to do is drop that test variable, and instead I want to destring this variable. Let's find where I wrote that so I don't have to do it again. There we go. And instead of generating a new variable, I'm just going to say replace the old variable. And once we do that, if you describe the variable now, you'll see that it is an integer. And just to make sure, we can go ahead and browse it. And you see that it is displaying in white here, meaning that it is a numerical variable. So the whole purpose of generating that test variable was just to make sure we know what we're doing before we erase or overwrite another variable. Now let's go ahead and try to destring some of the other variables. Let's see, which other ones do we have still? 2004, here's another one, the string. So let's go ahead and try to destring that one. I'm going to destring the value in 2004. And let's just go ahead and generate test to be safe. We get a message from Stata. This is not as nice of a message as we received before. It says that this variable contains non-numeric characters, so there's no generate. It refused to generate a new variable. Actually, if we go and look at our variable list, we would see the new one right here, test, but there's no test. Stata refused to generate the variable because there are characters in it. So let's take a look real quick. Again, it's a small data set, so I'm just going to say list. We can see it in the review window. List v2004. I see numbers. Oh yes, this is the one with the $sign. So what we want to do is use an option in dstring, and I'll show you in the help file where you could have read about this. Because if you come across this issue and I'm not here to help you, the first place you should go to is a help file. So let's say you receive this error, you're not sure what to do. I'll go to the help file, and I'll start looking around at the options. Now you can see here, one of the options is ignore. And if you read the description, it says remove a specified non-numeric character as characters or as bytes and illegal Unicode characters. So the main point here is this is telling you what characters dstring should ignore when converting the variable to a number. So let's go ahead and try that. I'm going to go and look at my history. I'm going to copy down what I wrote before, but in this case, I'm going to say ignore. And since we're talking about a string, we want to put quotation marks around it. That's how Stata identifies a string. And I'm going to say ignore the $sign whenever you see that. Now we get a message saying that the character $sign was removed. That's great. That's what we wanted. And test, the variable test, was generated as an integer. So this should have worked. Let's go ahead and list the values and make sure they compare. And I just like including team, just to remind myself what I'm doing. Although it's not necessary, it's always fun to just look at these values and see what teams were worth. So I'm going to once again list team, the test variable, and now the value in 2004. And sure enough, the numbers do compare. The Washington Nationals went from being an empty space when it was a string to a missing value. This dot is what the missing value means when it's an integer. And as you can see, the $sign was removed from 832, and we just copied over the numbers. So everything looks good here. In this option to remove characters, you're going to use often. Now I'm going to show you a little more advanced data cleaning and data exploration techniques here that'll make this process a lot faster for you. Let's try to find another variable that we need to destring. So I'm going to type right now D for describe. I can type as little as D, and you'll notice I wrote capital V and a star. A star in Stata is a wildcard, meaning anything can be written after V. When I do that, it displays every variable that starts with the letter capital V and has anything else after it. So this is one way to use shorthand, and it's very useful, especially when you name your variables in a similar fashion. Now looking at this, I can see we still have some string variables. I'm going to be careful with 2016 because if you recall, we saw that had M's and B's for millions and billions. I don't want to de-string those, ignoring the letters, because again, then $1 billion value will look small relative to the millions. We need to come back and fix that. But I will go ahead and de-string every variable we have to between 1990 and 2015. What I can do is simply say de-string v 1990, and then I can use what looks like the minus sign to say through v 2015. Now you got to be careful when doing this. You want to make sure the variables are in order. So if we go and look at our variable list, you see they are in chronological order. So when I say v 1990 through v 2015, it'll do all of these variables. Actually, it'll even do test. Even though test does not look like a v variable, it is in between v 1990 and v 2015. So I'll just do that so you can see the result. And we want to say ignore any values you see that look like a $sign. We also saw N and A. So we'll include those in there as well. And I forgot to specify whether we want to replace or generate new variables. And I'm pretty confident we're doing it correctly. So I'm going to go ahead and say to replace all the old variables. Now this is something nice about Stata. It yells at you in red when you've done something wrong. The most common thing undergraduate students do is immediately say, I'm not sure what to do. Let me ask a friend or Professor Kerr whenever they get an error without actually reading the error. Stata is pretty good at telling you what you've done wrong. So your first step should be to read what Stata tells you and then try to figure out how to correct that. And so here it's pretty obvious. We're going to type replace. And we get a ton of messages. So it looks like v 1990 to 1997 was already numeric, so there's no reason to de-string it. v 1998 did have characters N and A removed. Now it's an integer. That's nice. And scrolling down, it looks like we don't replace the variables that are already numeric. We do replace those that weren't, but we do have some issues. For v 2007, 8, and from 10 to 15, Stata is telling us the variables contained other characters that we didn't notice. So there was no replace. Now what are those? We could look through here. It is quite simple to do so here because our data set is small, but sometimes you'll be working with data sets that have literally millions of observations and perhaps hundreds of variables. So it's not a simple process to simply look through it like an Excel spreadsheet. A very useful command for this purpose is charlist, which stands for character list, charlist. So I'm going to type charlist, or charlist, however you want to read it, v 2007, v 2008, and v 2010 through v 2015. What are these characters we're missing? Oh, too many variables specified. So looks like I forgot that I can only do this one variable at a time. Let's go ahead and do v 2007. So this very useful command will display all the characters in the variable, and we can easily identify now that there's commas. I forgot, we did see commas, didn't we? So now this tells us we should try our dstring command again, and this time include a comma. And when I do so, I'll scroll up and notice that these were already numeric. We already replaced a lot of these. And for the rest, they're now replaced as integers because that comma was removed. And so everything looks to be a numerical variable now. Let's check. I'm going to describe all my v variables. And sure enough, we have floats and integers. And the one string, which is that 2016, we still need to take care of. Now, just out of curiosity, I wonder why those are floats. Let's look at v 1990 and 1991 side by side and see why we have a different storage. And sure enough, v 1991 has a decimal. So some of the values do have decimals. We can't store it as an integer because that's not an integer. Now, is there an issue in storing variables these different ways? It's not really a big deal. This is fine to leave as is. The integer takes less memory because it doesn't have to keep track of decimals. Whereas here we do have to keep track of decimals. Now what that means is this number 200 might actually be stored as 200.00000. And Stata is keeping track of those decimals, even though we're not displaying them here, to the right of the decimal. Or keeping track of those numbers, I should say, to the right of the decimal. But it doesn't affect too much here, so we don't need to worry about it. If we get to a place where those tiny details matter enough, I will go over when you might want to store everything in a similar format. Okay, so it's time to deal with that 2016 variable. Let's take a look at it again. So the problem we're going to have here is if I destring this, getting rid of those dollar signs, and the B's and M's, this 1.3 billion will just be 1.3, whereas this 900 million will be 900, making the Blue Jays look a lot more valuable than the Nationals, when in reality, the Nationals in this particular year were worth slightly more. And by slightly, I mean 400 million. Slight in Major League Baseball terms, I guess. Now we're going to have to deal with this in a little more manual fashion, because what we want to do is definitely get rid of those dollar signs, but we need to change the numbers, which are now strings, when we see a B. I think the most reasonable thing to do is convert all these to millions of dollars, since all our other values are in millions. So really what we want to do is take any value with a B, multiply it by 1,000 to get it into millions, and then destring the variable. Well, the problem is that's not possible, is it? We need the value to be a number in order to multiply it by 1,000. So first, let's talk about how we can refer to these characters in Stata. A useful command here is substring, substr, and then parentheses, we can write a variable name, which I will do so here. I'll write v2016, and I want to, let's say, count how many of these teams have a B at the end. So what I want to say here is count if the substring, so a particular small piece of the string variable, and which part? Well, we're looking at the last character. So I will actually say here -1, 1 equals, double equals, and then in quotes because it's a string B. And I get the value 17. Let's talk about what I just did here. So I'm telling Stata to count how many rows, how many observations satisfy this logical statement. The command substring splits up this string variable into only the characters we want to look at. The first value is where to start looking, and the second value is how many characters to look to the right of that one. So when I said -1 here, I'm actually saying start from the back, start from the last variable, -1. This space here is actually a character as well. That would be -2. This 3 would be -3. The decimal is -4, and so on and so forth. If we wanted to start at the front, this dollar sign would be 1, the first position. This would be 2, decimal 3, and now the 3 would be referred to as 4 because we're counting from the front. So here I said, look at the substring. This is the entire string. Look at the substring starting at -1, which is B, and the substring has a length of 1, which means it's just B. So I said, count the number of times you see that last character equal the letter capital B, and I got 17 back. Now to show you counting from the front, I can repeat this command and instead say, count how many times that first variable equals dollar sign. Should be all of them. And I get 30. Just to show you a little variation, count if the substring of the 2016 value, starting at the first position and going 3 to the right, including the first one, how many times is that equal to $1 point something? And so here you can see how we can use this, using more than a single character. We can make this as long as we want. And so we see here there's 11 teams that start with $1 point something. Now those are all going to be billions, right? Because you're not going to have any team worth 1 point something million. But again, the point here is just to show you how to use this command. So let's think about how we should handle this. Again, we want to multiply these billion-dollar values by 1,000 to make them into millions. I can't multiply them right now because they're string variables, but I can't destring them because if I do, I won't remember which one was billions. The B will be missing at that point. So what we need to do is keep the information of which one had a B, then destring the variable, and then we can multiply by 1,000 any one of those rows that had a B. So the thing we're missing here is how to store that information, which one had a B. Well, using this substring command I just showed you, we can generate a new variable, say equal to 1, if it has a B, if that row has a B, and equal to 0 otherwise. So let me show you how to do this in a couple steps, and then I'll show you a shortcut. First, we can generate a variable, let's just call it B, equals 0. And if I do that, let's go ahead and list team, value in 2016, and B. So I simply made a variable that's equal to 0 no matter what. I didn't give it a logical statement, so it just always equals 0. Now we want that to be 1 for these 3 observations, and any other that end in B. So the way we do that is we use the command replace. So let me just show you, for example, I could say replace B equals 1. And if I did that, now all the B's equal 1, right? I've replaced the values of the variable, but obviously I only want to do that when there is a B at the end of 2016's value. So let me start over again. I'm going to say replace B equals 0. Let's change it back. And you can see 31 changes made. So at this point, I'm comfortable with the command. I'm not going to list it again because I'm pretty confident that changed it for everybody. And instead, what I want to do is say now replace B equals 1 if, only if, the substring of that 2016 value, -1 to 1, that last character equals B. So you see I can combine these. I can combine the replace command with the logical statement using another command that's telling Stata to look at this particular character. As you can see, there were 17 changes made, which is a good sign because we saw 17 incidences of the B. So let's list it one more time, that subset of our data, and see if that worked the way we thought it did. And it's looking good. I got a B, I got a 1, I got an M, I got a 0, and it looks like everything worked out the way we thought it should. So this is great. Now I can feel free to destring these variables, get rid of the B and the M, because the information I want to keep is stored right here in this variable. And then I know which ones to multiply by 1,000 to convert them to millions of dollars. So let's do that. I will go ahead and say dstring B 2016, and we're going to ignore what characters we have. Dollars, M and B. I think that should be all. Stata will tell us if it's not, right? And then I'm going to say replace, because I'm confident we're doing the right thing. Stata removed a dollar, it removed a space, I told you that was a character, M and B, and replaced them as double. That is also a numerical storage. It has the most number of decimal places possible. It's called double precision. It's the most precise numerical variable you can have. I'm not exactly sure why Stata chose that here because we only have a couple decimals. It's unnecessary, but it's fine. We'll keep it. Now let's take a look at what our data looks like now. I'm going to list the team, 2016, and B again. And so here's the problem that we foresaw happening. This 1.3 looks much smaller than 900, but in reality, it should be a bigger value. But that's okay, because we have that information stored in this variable here saying that this is a value that should be multiplied by 1,000. So finally, we'll make that replacement. I'm going to say replace V 2016 equals V 2016. So let it be the same value times 1,000. But we don't want to do this to everybody. We don't want to do this to every team, right? Only if B equals 1. Once again, I see that 17 real changes were made, which is exactly the number we expected. So I'm going to go to my history. Oh, that's variables. And just click list again so I don't have to type because I'm lazy. And sure enough, we see that is no longer 1.3 for Washington Nationals. Their value in 2016 is now listed as $1,300 million, which is the same as 1.3 billion. So scrolling up here, I see all the ones have 4 digits as they should. And now we finally have a clean data set where all our variables that should be telling us what the value of an MLB team is in numbers are telling us that in numbers. Now Stata can recognize what we as humans could understand just from looking at the raw data. Whether we see it as a string or numerical variable, we understand 1.3b means 1.3 billion. Stata does not. First it saw it as a string, then when we destring or destrung, I don't know how to say it, after we used the destring command to convert it to numeric, Stata saw it as 1.3, not 1.3 billion. And so since every other value was stored as millions, we wanted to multiply that by 1,000 so that we could in the end get 1,300, and you and I understand that as millions. Now if we want to be really clean, we can go ahead and drop b. Now that variable's gone, we don't need it anymore. Sometimes it's useful to keep these things so that if later in your research you find that there's some values that don't make sense, you might want to keep this to show which ones you transformed because you may have done this wrong. And then that'll give you a clue if all your mistakes that you might find later have a b equals 1, that might tell you, you know what, you did this step wrong. These are the ones that have mistakes. You should go back and look at what you did. But here, of course, we did it right. So I went ahead and dropped it because I know it's right because, well, because this was a simple operation and I've done it a million times before. Now, one last issue we're going to have, because what I'm going to have you do here is calculate the return on investment of owning a team. So let's browse the data again. Once again, we have each MLB team and the value of the team across the years. And in general, this number is going up. So what we're going to do here is calculate the return to this asset, a baseball team. How much value are you gaining on average per year? How much is it increasing? And then we would like to compare that to, let's say, the S&P 500. Should you, if you're able to, purchase a baseball team over, say, the S&P 500 index of stocks in America? Which is a better investment? Now, a problem here is, as you know, we want to merge this with CPI data so that we can convert all of these dollar amounts into the same year. And again, typically we use the last year in the data set or today's CPI. For this case, let's just say 2016. So we want to convert all these values to 2016 dollars. However, the problem is, if you recall, when we merged the CPI to our data before, each row contained a year variable that we merged the CPI with. The problem here is the year variables are actually columns. The year is increasing with column. So I'm not going to be able to merge that because this is not in the right shape. What we'll have to do is reshape the data so that it's displaying these years as rows. And perhaps what we'll need is the team names to be columns. So I probably want Arizona Diamondbacks here in each row to give me a different year for Arizona. Then the data will look like our previous video and we'll be able to merge with the CPI. So to do that, we use a very, very useful tool, or command I should say, called reshape. And don't worry about using this command. Zoom in a bit. Every time I use this, except for maybe once in my life, I have had to use the help file because for some reason it's just a difficult thing to remember. I even saw one sports economist online a few years back celebrate the first time he ever used reshape without using the help file and said this was a life achievement. You know, something like, this is a bigger life achievement than any publication I've ever made, is correctly using the reshape command without looking it up. I can sympathize. So here's what we're looking at. Go ahead and read this. You will need to look at it. Even if I explain it to you here, you'll need to look at the help file. And now when you do it wrong, Stata actually throws up this image, which is so famous, I think, amongst Stata users. It'll throw that up in the error message, telling you, hey, remember, this is what you should do. So what we have right now is wide data. Our individual, is a team, right? So 1 and 2 would be like Washington Nationals, Cincinnati Reds. The stub we have here for us is V. And then you see here stubs are listed as 1, 2, and if you can think about it, it's like having variables that are in order with numbers that increase. Now our number doesn't start as 1, that's fine, it starts at 1990, but it does increase to 91, 92, 93, and so on and so forth. And then we have numerical values, which for us are team values. So what we want to do is reshape our data from this wide format into what's called a long format. We want that stub to stay, which for us would just be V, which means value. Okay, so we'll just have one variable, that's the value. Our I is the team, so we might have Arizona listed here. See, again, at first I was thinking we would want Arizona in the columns, but again, the picture in my head was wrong, which is why I always come to this reshape help file. We'll actually have Arizona in the columns, but then next to it will be the year. Now, how do I know this 1, 2 is going to be our year? Because if you look here, what we're going to do is reshape from wide to long. We're going to write the stub, which is V, and stub means variable stub, right? Our variables are V1990, V1991. The stub is the common beginning of the variable, and they all have the V in common. So we're going to write reshape long, V, comma, and then I is where we say what the individual level is, which for us is team. So inside the parentheses, it has I. This might be why it's confusing to a lot of people. We're going to write team. The J, as you can see here, is the new variable that doesn't exist right now. For us, that's going to be year. We're basically converting this 1 and 2 into variables. So those values that are in the variable name, for us 1990, 91, will become values in a new variable, which we'll obviously call year because that's what they represent. So let's just go ahead and copy this because I will forget it. And we'll paste it. We'll paste it below. And again, our stub is V. The I, the individual observation, is our teams. So I'm going to write team, that's the variable. And the new variable J, we're going to write year. Now, as you can see, this worked well, I presume. Let's take a look. This data tells you what all your J values are, and you can see they go from 1990 to 2016. That's what we wanted. The data went from wide to long. The number of observations, we had 31, we now have 837. And we should be able to confirm that makes sense. How many years do we have? We have 27 years and 31 teams. So I'm going to do something real quick. I'm going to say display 27 times 31, 837. Yep, that's how many observations we should have. We should have 27 years for each of the 31 teams. That makes sense. And as you can see here, I don't know if I covered this before, we can use Stata as a calculator, as you might expect. The number of variables went from 29, remember it was wide, to only 4. We should have team, year, value. Well, that's only 3. Let's see what else we have. We might have something else. It shows you here that it created the J variable, which has 27 values, one for each year, and we call it year. And it also showed you it converted all of these values in these variables to just one variable called V. So let's take a look at what this looks like. It's a small data set, so we can just say list. Let me scroll up real quick, see why we have 4 variables. Actually, it's no longer small. Let's not do that. Let's browse. I forgot we just reshaped it. Ah, you see here I still have that test variable. So it also reshaped the test variable for each team. And we don't need that anymore, so I'm going to drop it. We're going to drop it like it's hot. Drop test. Okay, now the world makes sense again. So as you can see here, we're missing some values for Arizona Diamondbacks because they didn't exist in 1990, and we didn't have the value in 98. We started seeing the value estimated in 1999. You can also see here there's a weird decimal for that year that's stored as double precision. This is not going to affect our estimates too much because the decimal is so small, and the short explanation for this is all the numbers in these programs are stored in binary, essentially. And binary can't represent each number perfectly. So this is as close to exactly 271.7 that Stata can get with double precision. Again, it's not going to affect the estimates since we're going to round to the nearest, tenth of a number. And everything else looks good. This looks like it accomplished what we wanted. So now we can merge the CPI with each of these years now that they're in rows. And once we do so, once again, we can convert all these values into, say, $2016. Once we do that, we can calculate the return on investment by seeing how much these values increased for each team over time. Now, as a hint, there's many ways to do this, but what I suggest you do is go back and read that help file on reshaping the data and reshape it back so that the values, once you've transformed them, are in rows again. Then it's easier to make a variable saying, how much did this increase? Because they're all in the same row. So once again, I suggest you type help reshape and look at, now that you're in the long format, how do I get it back to wide so those values come back up here? So that's my hint for you. So I hope you have fun with this assignment, and just to make it a little more fun, because I know in the beginning we talk a lot about baseball, we will move on to other sports. To make it a little more fun, I've added this year an extra credit portion where I'll give you another 10 points if you repeat this assignment, calculating the value, the return to owning a sports team compared to the S&P 500 for a different league. Choose any league that you like and choose the latest 10 years up to today, whatever data you have. That'll be more fun for you because it'll be a league that you're interested in. And if you do that, I'll give you an extra 10 points. All right, have fun, guys. While editing this video, I just realized I never showed you the shortcut I promised in making that b variable. We've already got here the variable transformed, so I guess I'm going to have to start over with the data. So I'm going to show you real quick how to do that. And if Stata says, nope, you've changed the data, you're not allowed to load a new data set, you can use the option replace, telling Stata it's fine. So again, remember the problem was we had a variable 2016 value with B's and M's, and I was first going to make a variable that was equal to 1 whenever there was a B and a 0 otherwise, so that I could keep track of which rows I needed to multiply by 1000 after destringing the variable. So here's the shortcut I promised. We could, instead of taking all those steps, we could have simply have said generate B equals, and then I like to write in parentheses. You don't have to. It just makes it look cleaner when I read it, in my opinion. I write a logical statement. So I will write substring of B 2016, negative 1 to 1, meaning that last character equals B and quotation marks because it's a string. So here what I've written is a logical statement in parentheses. You don't have to include the parentheses. I do it because it's easier to read. For me, it looks weird to see an equals and then another equals even though it's a double equals. So in this parentheses is a logical statement that is either true or false. We call that a Boolean. So the variable that generates B is a Boolean variable. It's either true or false, 0 or 1. And when you write a logical statement like this, that could be either true or false, Stata recognizes that you're trying to create a variable that's a 0 or 1. Whenever this statement is true, it'll give us a 1. Whenever it's 0, whenever it's false, it'll give us a 0. So let's look and see what we just created. And I'll add B to our list. And as you could see, we could do what took us a few steps before. We could do that all in one step by simply saying generate a variable that equals 1 when this statement is true and the statement is the last character is B. This is a very useful thing to know because you'll be generating these kinds of indicator variables often when you want to keep track of when certain things are true for each row. So this is a nice shortcut to know, and I hope you find it useful.